Have you ever wondered what lies beyond Neptune in our solar system? As we venture farther from our home planet, we encounter something truly fascinating, the Kuiper Belt. This vast, icy wilderness stretches beyond Neptune, filled with a multitude of celestial bodies. Dwarf planets, comets, and smaller objects, all frozen in time, dot this expansive region. It's a realm that spans from approximately 30 to 50 astronomical units from the Sun, a testament to the incredible scale of our solar system. So let's dive into the mystery that is the Kuiper Belt. Our journey begins billions of years ago with the formation of the solar system. Picture a vast cloud of gas and dust swirling in the cold depths of space. This was the solar nebula, the birthplace of our sun and all the planets. But it was also the cradle of something else, something less known, but equally fascinating. The Kuiper Belt. The Kuiper Belt formed in tandem with the rest of the solar system. As the sun ignited and the planets began to take shape, the outer regions of the solar nebula remained a cold, chaotic frontier. Here, countless icy bodies coalesced from the remaining dust and gas. These would become the objects of the Kuiper Belt, scattered in a vast region beyond Neptune, stretching from 30 to 50 astronomical units from the sun. But the story of the Kuiper Belt's birth doesn't end there. Enter Neptune, the outermost gas giant. As Neptune migrated outward in the early solar system, its immense gravity stirred the pot, scattering these icy bodies and shaping the Kuiper Belt as we know it. Some of these objects were flung towards the inner solar system, becoming comets. Others were propelled into far-off, eccentric orbits. Neptune's dance left a lasting impression on the Kuiper Belt, sculpting its structure and populating its vast expanse. Studying the Kuiper Belt is like peering back in time. The icy bodies it contains are relics from the dawn of the solar system, largely untouched by the heat and activity of the inner planets. They're frozen snapshots of the early conditions that gave birth to our home, offering invaluable insights into how planets form and evolve. By studying the Kuiper Belt, we're not just exploring a distant region of space, we're investigating our own cosmic origins, piecing together the puzzle of how our solar system came to be. Thus, the Kuiper Belt is like a time capsule preserving clues about our solar system's infancy. Now that we know how the Kuiper Belt came to be, let's talk about its residents. The inhabitants of the Kuiper Belt, known as Kuiper Belt objects or KBOs for short, are a diverse bunch. They're made up of frozen ices, the remnants of the early solar system. It's like a cosmic freezer out there, preserving the building blocks of planets for billions of years. But these aren't just boring blocks of ice. No, they're far more interesting than that. KBOs come in all shapes and sizes. Some are small, no bigger than a city. Others are massive dwarf planets in their own right. They're as diverse in color as they are in size, with surfaces ranging from brilliant whites to dark reds. This variation in color is believed to be caused by the complex interaction of sunlight with the ices on their surfaces. It's a stunning, colorful display out in the cold, dark depths of the solar system. But the surprises don't stop there. Some KBOs even have moons. Yes, that's right, moons. These moons suggest that there has been geological activity in the past. Imagine it. Out there beyond Neptune, these icy bodies were active, changing and evolving. They were not just passive blocks of ice floating in space, but dynamic worlds in their own right. What's more, the moons themselves can provide valuable clues about their parent bodies and the early solar system. By studying these moons, scientists can glean insights into the history and formation of their parent KBOs, and by extension, the early solar system itself. In conclusion, the residents of the Kuiper Belt are more than just icy bodies floating in space. They're diverse, dynamic worlds that tell the story of our solar system's past. Their varied sizes, shapes, colors, and the presence of moons all point to a complex history, a history that we're only just starting to uncover. These icy bodies with their unique features make the Kuiper Belt a fascinating region to explore. You might be wondering, what role does the Kuiper Belt play in our solar system? Well, let's dive right in and uncover the mysteries of this distant region. The Kuiper Belt, in essence, is a vast cosmic freezer, a potential source of comets. Now these aren't your everyday celestial bodies. These comets are icy emissaries from the outer solar system, carrying with them the primitive material from the time the solar system was formed. When these icy bodies journey from the far reaches of the Kuiper Belt into the inner solar system, they leave behind a trail of gas and dust, creating a spectacular light show that we often witness as shooting stars. But there's more to these comets than just a pretty display. They offer scientists a unique opportunity, a window into the distant past. You see, these comets are like time capsules, preserving the original material from the solar nebula that gave birth to our solar system. By studying these comets, scientists can glean insights into the early conditions of the solar system and the processes that led to the formation of planets. This information is invaluable in piecing together the cosmic puzzle of our solar system's origins and evolution. But the Kuiper Belt's role doesn't stop there. Its gravitational interactions with Neptune have shaped its structure and dynamics, influencing the orbits of its resident objects and possibly playing a part in the formation of resonant populations and binary systems. Indeed, the Kuiper Belt serves as a launch pad for these icy messengers from the distant past. Exploration of the Kuiper Belt is a relatively recent endeavor. Our journey into this distant frontier began in the 1990s, a mere blink of an eye in astronomical terms. The pioneer of this exploration was none other than the New Horizons spacecraft. Launched in 2006, New Horizons embarked on a 9-year voyage across the vast expanse of space, traveling more than 3 billion miles to reach the outskirts of our solar system. Its mission? To shed light on the mysteries of the Kuiper Belt. And in 2015, after a journey that spanned nearly a decade, New Horizons made history. It delivered the first ever close-up images of Pluto, the most famous resident of the Kuiper Belt. These images unveiled a world of icy mountains and plains, a heart-shaped glacier and a hazy blue atmosphere, changing our understanding of this distant dwarf planet. But New Horizons' mission didn't end with Pluto. It continued deeper into the Kuiper Belt, sending back valuable data and revealing more about this distant region of our solar system. Yet, the exploration of the Kuiper Belt is far from over. Future missions are already in the works, aiming to delve deeper into its icy depths. Scientists are planning new observations and spacecraft to further unravel the mysteries of this region. These missions will not only seek to discover more about the known objects in the Kuiper Belt, but also to find potential new dwarf planets and other celestial bodies. This exploration is essential in our quest to understand the history of our solar system and the processes that led to the formation of planets. The Kuiper Belt, with its icy bodies frozen in time, holds the clues to these cosmic mysteries. As we continue to explore the Kuiper Belt, who knows what exciting discoveries await us? Our journey into the unknown continues, as we push the boundaries of our knowledge and explore the final frontier. The Kuiper Belt is a testament to the endless wonders of our universe, a reminder that there is always more to discover. As we conclude our journey through the Kuiper Belt, let's recap what we've learned. This vast region beyond Neptune, spanning from 30 to 50 astronomical units from the Sun, is a cold frontier teeming with icy bodies. These range from dwarf planets and comets to smaller celestial objects, each one a relic from the early solar system. Born from the same solar nebula as our own planets, the Kuiper Belt's formation was influenced by Neptune's gravitational pull. This interaction played a significant role in shaping this distant realm and the bodies within it. As we gaze upon these distant objects, we're not just looking into space, but also into the past, witnessing firsthand the conditions of the early solar system. Amongst the icy inhabitants of the Kuiper Belt, we find a diverse array of sizes, shapes, and colors. Some of these objects even have moons of their own, suggesting a history of geological activity and complex processes. Each object tells a story, providing us with clues about our solar system's history and the formation of planets. The Kuiper Belt isn't just a distant curiosity, but an integral part of our solar system. It's a potential source of comets, those icy messengers that streak across our skies, and a treasure trove of information about our cosmic neighborhood. Our exploration of the Kuiper Belt, which began in the 90s, has already yielded incredible insights, with the New Horizons spacecraft providing close-up images of Pluto in 2015. But this is just the beginning. Future missions and observations are planned to delve deeper into the mysteries of the Kuiper Belt as we continue to push the boundaries of our knowledge and our capabilities. The Kuiper Belt, a treasure trove of knowledge about our solar system's past, continues to fascinate and inspire us as we look to the stars and beyond.